Horizons and Computing, SERC Day, Social Ethical Responsibilities of Computing. We're going to have a bunch of talks and sort of discussions on topics related to this, kicking off with Kadeem Noray, who's a postdoc here at MIT in econ, right? And going to tell us about whether, or ask us the question of whether algorithms will make the world more fair. So give it up for...
Awesome. Thank you. I really appreciate the introduction. So I'm a future of work postdoc in the econ department. And generally what I do is I'm a labor economist. And specifically, I'm interested in the economics of talent selection and talent allocation in the economy. The title, Will Algorithms Make the World More Fair? Sorry about that. Does anyone happen to think they have an answer to that question? Yes? No? Okay. I think yes. I think I heard a yes. That's correct. I guess I'm done here. No. No. And it depends. That's actually pretty much going to be the answer that I'm going to come to, but we'll get there. The subtitle. A wide-ranging discussion, I think, also has some meaning here. My hope is that as I go through this talk, I'm actually going to be able to get some questions and thoughts from you all, and so there's going to be prompting. This is going to be less maybe a lecture and more of a structured conversation about some of these notions of algorithmic fairness and what they mean in practice. Okay. So I think a lot of people are thinking about this question. It's a question that's in the culture writ large, and so it's not uncommon to see headlines like this. The rise of AI puts spotlight on bias in algorithms, or headlines that let me look something like this. AI machines, they might be racist. Maybe even areas like health or life insurance, there's questions of bias. And so for years, I've been seeing headlines like these that suggest that, things are bad potentially. Maybe algorithms are actually going to make things worse. The only challenge is that, it's almost equally common to see headlines that look something like this. Biased algorithms are easier to fix than biased people. Or 5 ways AI is making the world a safer place. Fair AI, why everyone should profit from the AI boom. And so there's at least as much, for every concern, there seems to be somebody that thinks that this is going to ultimately be a panacea. And so what are the different ways of thinking about algorithmic fairness, whether or not it'll make the world fairer or better? In this discussion, what I'm hoping to do is I'm going to walk through 2 concrete case studies of algorithm use that are closely related to my research. And that's going to be using AI in recruiting for tech workers, and then also algorithmic cohort selection with an application to admissions. Through that, I'm hoping to discuss what it means to make algorithms fair in these contexts. The discussion part is underlined. I've mentioned this. I'm gonna, be asking questions and asking you guys to contribute. There are gonna be no wrong answers here. As you've seen, there's a wide range of views on whether or not algorithms are fair. And so I really am hoping this will, spur different people to give various ideas. I'm also gonna introduce 4 types of fairness that are discussed in the algorithmic fairness literature to give us some common language to maybe talk about these things intelligently. And then at the end, I have a bonus where I would like to discuss what might make humans distinct from AI in the context of work. I can pretty much say right now, I think that I'm probably not going to have time to get to that bonus, but we'll see. Okay. So the first case, which comes from a topic I'm researching, it's about considering humans versus generative AI in recruiting. So in order to understand this application, you need to know a little bit about the hiring process for tech workers for tech workers, specifically software engineers. And so the first part of this process, it starts with a recruiter screen. And there, what happens is that generally a human is looking at a resume and they're asking, is this resume good or is it good enough? Is this somebody that I should give an actual interview to? Roughly, in the data that I've worked with, roughly 50% of people pass these kinds of screens. And then the next part would be a technical interview where you actually do a coding test and the interviewer decides, can you code well enough to move beyond and for us to consider hiring you? And then the final thing would be the actual hiring decision. Of the people who make it through these two screens, do we make a decision to hire? And a question that a number of companies are asking themselves is, should the recruiters be replaced with generative AI? And by this I mean systems either built on or similar to ChatGPT, Claude, Grok, some of these large language models that have been incorporated. And in particular, so I'm going to be focusing this discussion around this first part where you're doing a recruiter screen. One thing I should say is that there are a lot of reasons that organizations are interested in using AI in this part of the hiring process. Oftentimes, recruiters don't necessarily have technical experience, but they're looking at resumes and they're making judgments on who should get a technical interview. And so there's reasons to think that there are mistakes made. And so, it's not. I think there's some justification to try and use generative AI here. It makes a lot of sense. Okay, so let's think about if we were to use AI in this context, what the hypothetical recruiting problem actually looks like. So imagine that you have an applicant pool, and what you're ultimately trying to do is select which candidates deserve an interview. You can also imagine that AI can observe. In this case, I'm just going to simplify things, and they're individuals that are orange and white. I'm going to assume that those colors are representative of some identity characteristic. So you can think of that as a demographic characteristic. It could be gender. It could also be race. They also observe resumes in this case. And that's going to have your education, your work history, et cetera. And so the first discussion question that I'd like to ask the audience is, what are the various ways that AI recruiting decisions might be considered unfair at this stage? And what I originally was going to do is I was going to have you guys turn to audience members next to you and have a discussion about this. Given the distribution of the audience, not everybody has someone sitting next to them. But I would actually, love to get answers to this question if anyone has thoughts. As the AI is making decisions about who to interview, what are ways in which you might imagine this decision being unfair, given these contexts? Yeah, sure. Actually, this would be if you guys can form into groups. How many MIT people does it take to be able to figure out how to form into groups? I don't know, but if you guys can handle that problem, then I'll give you guys 5 minutes to have a discussion here. All right, we have one minute left. Okay, we're at time. It sounds like there are some pretty intense conversations going on. So I'll give like 10 seconds. No, this is great. Actually, given your enthusiasm, do you guys want to share a little bit about what you guys talked about? I'm curious the various elements if somebody has a sort of synthesis.
Then, if the AI says, well, generally the orange people have more of the talent than the white people, it's going to be insensitive to the particular distribution of talent within the orange people, say, or within the white people, because maybe you're a white person who's got lots of this kind of talent being looked for. And then there was a sort of pushback to that as well. What else can the AI do? I mean, because all the characteristics it's looking at are going to be characteristics such that generally people with this characteristic have talent. It's not going to be able to look at the individual in that full specificity. So there was a kind of pushback to that.
That's awesome. So, in that back and forth, there actually are a couple of ideas that are common in the fairness literature. So one of them was being sensitive to the possibility that the AI could make different decisions across the orange and white groups. That would be akin to what's called group fairness, and there are different ways of thinking about group fairness. But, the tension associated with, like, say, qualifications or ability across groups, the tension there gets towards individual fairness, or what's oftentimes called individual fairness, or is represented by the similar treatment principle. People who are similar should get the same sort of outcomes. And so if two people are equally qualified, you'd expect them to get sort of treated similarly. So it sounds like some of those ideas were floating around there. Does any other group want to share maybe additional ideas that were raised? Yeah, in the back, yeah.
Separation between the orange and the white people. If people have, even with two people have different experiences, or the same experiences, people may have different types of lived experiences that where they're bringing an extra story, or they're bringing a different perspective, or they see a particular bias that's a glaring flaw that people are not looking at, and that could be, I was telling him an example like in the automotive industry where so many women and children were being killed by the airbags, and they were wondering, why are they killing, why are they dying? And they brought a female engineer, and the first thing goes, most women and children are not as tall as men, and you're suffocating, breaking the rib cages, you're suffocating them. Why don't you just, I mean, it sounds something simple, why don't you just adjust it to the fact that who actually is in the car? And you're like, oh, we didn't think of that. But it's not, it's just an example of having different viewpoints and different lived experience that can contribute to, a group.
That's great. So that actually adds some additional concepts that I'll talk about a little bit, but that are also very important. So there could be a narrow sense in which you're thinking about hiring people based on like measures of ability, but that might not take into account the fact that there are other dimensions of ability that actually contribute to being able to do something better. And so that would be, I think, generally in the area of outcome fairness. And so, one example that I think of a lot in the late 40s, the Coca-Cola actually pioneered in marketing. They hired a black marketing manager into their company, and at a time when a lot of organizations weren't doing that. And the reason that they did it was because they were like, hey, I mean, we're trying to sell products. Now, Coca-Cola is not necessarily great for you, so that's a caveat to this. But we're trying to sell products, and we don't really know that much about black communities. And so maybe this person's perspective would add something to our team that would make it easier for us to, market to these groups. And so that was a case where actually, I don't know if I've seen quantitative exact analysis of this, but at least by their reports, it was very helpful that they made this decision and they were able to actually sell their product more widely. Now, yeah, I like safety as a better example, just because, Coca-Cola. But are there any other ideas that seem additive to this discussion, things that maybe haven't really been discussed so far?
Really one identity characteristic, but there's a lot of other hidden metadata that can be observed by the AI that can also be used to make things less fair or more biased, right? Just from things associated with where you went to school, where you work, where you live. There's a lot of stuff that's, even though it's not explicitly called out, it's going to be embedded in there, and AI will definitely find it and use it in its decision making.
That's a great point. So yeah, I've made this a simple example of, about one identity characteristic, and that's the focus. But of course, you can infer all sorts of different identity characteristics. Something as simple as a name could have information about both, say, your race and your gender. And so that's also a great observation. Okay, so this is anyone else want to contribute any ideas? I don't want to cut anyone off. Yes.
My colleague mentioned that if the white-orange pool was divided between physical attractiveness or not physically attractive, that neither Abraham Lincoln nor Jack Ma could have jobs.
Okay. So I actually think that does raise an important consideration. What kind of characteristic is this characteristic, that separates between orange and white? So you might wonder, is it a protected characteristic? So that would be like race and gender that might have different implications, particularly legally? Or is it not a protected characteristic? So I think technically, I don't believe that attractiveness is a legally protected characteristic, though I could be wrong about this. But still, we have these intuitions that maybe that's not the right way to be selecting people. But that's a good point. Okay, so I'm gonna now go. Oh, yes.
We are talking about AI's biases here, but the thing is AI need to follow someone's instruction of doing this hiring processing. So what happened is that particular individual or company actually is another bias source, because it will give certain instruction how AI should behave, how AI should select, right?
Mm-hmm.
And that another source of biases.
Totally. So actually, that we've covered all of the. Now we've covered all the four different sorts of fairness I wanted to talk about. So, but previously we talked about individual fairness, group fairness, and then outcome fairness. But the last one is actually called procedural fairness. And so part of the procedure of deploying the AI requires somebody giving some input into what the AI is doing, or what counts as an outcome that would be good. And so there are other elements there, but I appreciate adding that as well. So right now I just wanted to make sure to get all of these concepts on the table and see whether or not the four buckets that I'm going to discuss seems to encapsulate most of what we've said. So first concept, as I've mentioned, individual fairness. And a lot of what people leverage here is something called the similar treatment principle. At the individual level, if you have two individuals that are very similar in a number of characteristics, this could mean like sort of merit-based measures or measures of performance. Then one way of thinking about fairness is that those people that are similar should be treated similarly. But another aspect would be group fairness. And so here there are a variety of notions that actually oftentimes conflict. So the first one that's oftentimes used in the algorithmic space is what's called statistical parity. And so what statistical parity says is that the judgments made by the algorithm should be the same on average across the groups. So if we had white and orange in its interview decision, they should both be equally likely to be given an interview, regardless of their group. Now, in the first group that talked, I think raised some things that are concerning about this. What if there's differences in capability across the groups or qualifications? This notion ignores these kinds of concerns. A more refined notion is something called equalized odds. And so here, the idea is that if you are qualified for the position, or if you if you will be deemed as worth hiring in a technical interview, you should have the same likelihood of being given an interview, regardless of which group you're in. And so this is slightly different, and it actually takes into account, your underlying qualifications for the position in this case. It's a related notion is this idea of counterfactual fairness, which is the prediction that the algorithm makes or the judgment it gives, whether or not you get an interview, should not be affected if you were to just shift the person's identity characteristic. And so that's also closely related to this equalized odds notion. And then, one other thing that I'll mention is this idea of intersectional fairness. So we were talking about one characteristic, but there could be many demographic characteristics, and you might care about not just having fairness across the two characteristics, but fairness when those two characteristics interact. And so it's basically applying the same notions, but let's say you're thinking about race and gender, you're doing it for all the race and gender categories. So the third notion of fairness, outcome fairness, there are a lot of different things that you could put in this category, but oftentimes things like diversity and representation are included into this. So here you have some goal of representing some group, and that's a kind of outcome in the organization. For example, you want to make sure you're like nationally representative or something like this, or you would like to achieve some sort of diversity. There are lots of reasons that relate to further outcomes why you might want this, like the example of somebody bringing in lived experience, making you more productive. But then, there are other kinds of notions that are related to this. So we want to make decisions that are beneficial to the people who we consider the worst off or the most disadvantaged. So a Rawlsian notion would also fall into this category. And then finally, procedural fairness. So here I'm thinking about things like the actual algorithm training process, or the data being used. Are we using data that already has certain kinds of biases in it? Something like what was raised just a second ago, the person who's making the decisions about how the algorithm's deployed would also count as part of the process, and we might want to make sure that that's fair in some way. Are there any other things that are outside of these four buckets that you guys maybe want to add? Because I don't necessarily think this is comprehensive.
Posed it, okay, but I would think that the problem is posed a little bit too narrowly, okay, in the sense that you're assuming that the applicant pool is the same, is fixed, right, or you're assuming that the number of people who get chosen from the applicant pool is fixed, right, for a given job or something, and in fact, though, these numbers are, they're not fixed, right, because sometimes disadvantaged people don't apply, they won't even try to apply to something that, so now now there are no disadvantaged applicants because none of them, you discourage them all and they won't apply. So, there are these feedback loops, I think, that go beyond the confines of the particular problem that you posed in that way. Just one example is, suppose the goal of this whole process should also be that if there's historically disadvantaged groups, right, you want the outcome for that historically disadvantaged group to be better, in some sense, overall. Okay? So, that's a kind of group fairness, the way you posed it, or outcome fairness. Okay? So let's say you have some job which you're trying to hire 1 out of 1 million people. Okay? So what I'm saying is that the cut, how sharp the cut is going to determine some kind of fairness, right? Because if you're trying to hire 1 out of 1 million people, or let's say 2 out of 1 million people, you're going to choose 2 candidates out of 1 million people, okay? And now you say, I'm choosing 1 man and 1 woman, okay? So now it's perfectly fair with respect to gender, right? Because you chose 1 man and 1 woman, okay? But the problem is, if you're trying to overall improve the status of women, kind of doesn't help. It's great for that 1 woman who got chosen, but what about the other 9,999 people? So it doesn't have a significant outcome for the group fairness. So that's what I would say.
I appreciate that conversation. Actually, is a natural transition to the next point that I want to make, which is about whether or not these kinds of fairness do they conflict with each other in certain contexts. And so I think you actually just posed a great example of a case where you might have statistical parity amongst men and women, and you hire 50-50, or you've achieved some sort of diversity there. But if it's the case that you care about outcome fairness in the sense that you're trying to improve the status of women through this decision, it might not have very much of an effect. There are actually cases where it might have a negative effect. So an example would be, imagine if the woman that gets selected is through a want of fairness, you sort of have this equality across gender, but the woman that gets selected is less qualified, and let's say that makes the company less likely to make that kind of decision in the future. And so then it actually could potentially hurt women moving forward. And that would be a case where you end up with group fairness at the sacrifice of a version of outcome fairness. these are just hypothetical examples, but people raise them in the real world. In general, I think that there are lots of tensions between these different notions, and it's difficult to have processes that hit everyone's notion of each of them. And so, in general, this part where you have overlapping, you have an algorithmic process that is fair in all of these notions. I'm not saying there actually are none, but in general, you're oftentimes making sacrifices, and you're not going to get all of these notions at the same time. Okay, so keeping this in mind, I'd actually like to jump back to the example that I've been running with, which is that of recruiting. And so what I'm going to do now is I'm actually going to show you some information, and I'm going to try and get reactions on whether or not it changes your thoughts on whether or not using an algorithm in this case is fair. And so going back, you have the orange group, you have the white group, and imagine that you actually deploy AI to make recruiting decisions. And the first thing that you see is that you actually see the differences in the likelihood of being interviewed if you're in one of these groups. And so here, the white group is being interviewed 55% of the time. Here, the orange group is being interviewed 50% of the time. Does this give you any information that's useful for assessing the fairness of using the algorithm in this case? Does anyone have reactions to this?
It could be something, depending on how large your sample is. If it's 4, it's not going to be meaningful.
Sure.
But it may be. You may also want to look at all the other fairness, the 3 other ones at least, to see where how it's behaving.
Sure.
In a sense, there's a trade-off.
So yeah, I think based on the definitions that I've given, this violates statistical parity. But whether or not that's the right thing or the wrong thing, how does it relate to other notions? I think more information is probably needed. So the next thing that you could reveal. Oh, one thing I should mention is I've done 4 and 4 here, but I'm actually not. The groups could be much larger than this or not. I'm mainly doing that for graphical representation, but I don't want people to over-index on the fact that it's just 8 people. Okay, so now imagine that you get additional information. So what this is it's a resume score. What the company has done is they've taken all of the characteristics of historical resumes of people who go through this recruiting process, and what they do is they predict whether or not you're going to actually pass your interview based on that information, and then they assign people. What this is the average percentile within the different groups of that score, and so it looks like here the white group has a significantly better resume along this dimension than the orange group. Does this change the way that we think about the initial difference in the decisions? I think the sort of natural thing to me if I were to see something like this would be maybe it's the case then that there are actually qualification differences across the groups, and so the fact that you're seeing a higher likelihood of being interviewed from the white group is in some sense justified. At least that's, I think, a way of looking at it. The final thing that you could reveal here is actually the true pass rate in the technical interview. So remember, the recruiters are making decisions about who gets interviewed. And then what if you knew the actual ground truth likelihood of someone from each of these groups passing the interview? And here it actually, the likelihoods look actually mapped on to, or very similar, or exactly the same as the likelihood of being interviewed. Does that change your view of whether or not the decisions made by this AI are fair?
Among people who've already got past the first.
That's a good question. So I should explain. So this information is it's on exact numbers, but it's based on a study that I'm actually currently working on. And here, actually, what we have access to is we have access to the interview pass rate for everybody in the sample, and then we go and we get AI to make judgments about who would they interview, based on the resumes that they're given. And so here, you don't have this selection issue where you only have outcomes for people who were selected by a human to get an interview. But there's no reason, that's not a natural, usually that's not going to be the case. But for this thought experiment, you say that's actually the ground truth information for everybody. Do you have a thought? Does that make a difference? And
the AI is performing the same way the human interviewers are. That the AI is making the same judgments the human interviewers, which doesn't necessarily mean that it's all fair, but just means that if there's bias, it's shared by the AI and the interviewer.
Sure. Yes. And so I should be careful so the AI is making decisions about who gets an interview, and then the interview pass rate tells you the actual interview that it's given, whether or not humans pass it. So what you're saying is right, that the AI is making decisions that are similar to the downstream interviewers. And if you think about that as what the AI is trying to do, they're trying to pass people who will be passed in this actual interview, yeah, I think that maybe it does mean that this is the AI is performing well, so to speak. Yes.
Go. You are basically using AI to do this job. What about if it's a human did a scoring? Is there any difference there? That's another angle to look at.
Yeah. So it is. So one thing that one could point out is the seeming discrepancy between the differences in the resume score and the differences in the interview pass rate, which is not quite. I'll get to your exact point, but. What that would suggest is that you're using some sort of a tool that's telling you how good this resume is, and you're using a population to make some sort of prediction here. But in this particular sample, it actually doesn't seem to be that effective. You would expect that the white group would do even better relative to the orange group in the actual interviews, which that happens all the time. You use historical data to make a judgment of the quality of the resumes, but in a particular sample that you're looking at, those predictions don't necessarily pan out. Now, so whether or not humans are scoring the resume versus whether or not AI is doing it is something that I'm actually not going to comment on. I think that could be an important aspect of this, but I do think that it's important to keep in mind that all this information, this is information that's about using AI to make judgments on these applications, but you can use AI or you can use humans. And so there's actually another comparison that might be important for understanding whether or not it's fair to adopt AI. How would humans make these kinds of decisions? And so what I've done here, these are exactly the same, because I'm assuming that there's the same resume score and that the actual ground truth hasn't changed. This is the exact same sample that's being judged. But there are differences between how humans are making interview decisions and how the AI is making interview decisions. So I think perhaps the most notable difference is that the magnitude or the sign of the difference is actually flipped between the white and orange groups. Humans are actually saying the orange groups should be interviewed at higher rates. And based on our previous discussion, it might be difficult to justify that based on the ground truth performance or the resume scores. It would appear that the white group is sort of more qualified on both those dimensions. Before I move forward, I want to see, does anyone have any thoughts on how adding the human information maybe complicates things or changes the way we think about this? Yeah.
There's also might be in this whole problem an opportunity cost. Whereas if you decide that maybe the humans are figuring that they may get some opportunity by interviewing more in the orange group. And you can't measure opportunity cost. It's so there's kind of a bias in the statistical judgment that you're going on the information you have rather than the information you don't have.
Sure. I think that there are a few ways that the notion of opportunity cost plays in here. So one is thinking about how costly is it actually to have humans review these resumes relative to the AI. It takes time, and humans could be doing something else. And so if you use AI, it could be a cost-saving thing. I think what you were referring to is, maybe there's a hiring initiative where what you're trying to do is you're particularly trying to promote a particular kind of candidate, and so you're more likely to be able to make an offer to a candidate from one group or another. And so we don't observe that, and so that's the kind of thing the human might care about. I think that those are great observations. I think the last thing that I want to reveal about this is, yes.
Question the initial grouping of what you do here, like in terms of, I don't know initially how do you categorize into this two population of orange versus white, right? But if you differentiate that into another angle, like looking at this population, divide into a different group, then the data you generate could be different too. So that's another thing I would look at how you do the division of the group and.
Yeah. So I've left the grouping vague, kind of on purpose, and you'll see why in a second. But yes, if you were to group people differently, these numbers would look different. Like let's say this is a gender differentiator, like the white versus orange. That's going to lead to certain results. But you'll say you then group by something like socioeconomic background or something like this. Then it's going to give you different results. That's a good observation. The last thing that I want to reveal on this is that so imagine that now the white group is what I'm going to call an overrepresented group. So in my context, it's overrepresented racial groups in tech. So that would be both Asian and white applicants. But then the orange group actually represents an underrepresented group. So this would be underrepresented races, particularly Hispanic and Black applicants. Does that change this picture at all once you know exactly what characteristic or what kind of characteristic you're looking at? Yes.
So what kind of job are you research-based?
What kind of job are they being? This is a software engineering job is what you should think of. Yes.
It seems to me that actually human selection shows that they are trying to create more diversity than the AI selection. Try to create more inclusion than the AI selection.
Yes, if I were to have tried to plant someone to give what I was looking for as an answer, that's basically the kind of intuition flip that I think I also had. So I think going into this project, I think that there's a thought. What if AI can de-bias humans? And I think generally that's seen as a good thing. That de-biasing is a good thing. In this context, it would appear that humans actually do have a bias, and they have a bias that's in favor of an underrepresented group. If you take these numbers to be real, they're not exactly right, but they're qualitatively correct. If you were to make the decision to switch over to AI selection, it might actually hurt the underrepresented minority group, but it eliminates bias, actually. If you're thinking of bias as different judgments relative to the ground truth of your qualification on the thing that's being judged. And so to me, I was like, when I saw this, it was actually it was pretty surprising. It made me sort of rethink some of these ideas. And I think, so, one question, I'm not going to make you guys go into groups again because actually this part has taken longer than I anticipated. But one question that I wanted to raise to the audience is, can discrimination be fair? Or is it always unfair by definition? If you see evidence of a bias, can it be fair? What sorts of things might make it fair? And so the second question that would go along with that: if no, why? If yes, what are some examples? I don't know if anyone happens to have thoughts on either of these questions right now. Sure.
This is your. I wonder I wonder what your decisions or thought processes around the extensibility of the fairness concept versus viewing fairness as one element of a larger strategic set of things, right? Because fairness winds up interacting with what I would have thought of as other strategic priorities, right? And so that liberates you from having to use fairness to explain certain kinds of dynamics that maybe it might be hard to use those four categories of fairness to explain.
Yeah, totally. So this is a talk that's focused on fairness. No, I actually think, but there's a totally, different thing. So when I talk about outcome fairness, that's the closest I get to talking about something like just, trying to do a good job in the, yeah, exactly. And so I think like productivity concerns or like, what you're actually trying to accomplish is another piece of this. I actually think you can bring it into a conversation about fairness by thinking about things like overall societal welfare. So one place where this oftentimes gets raised is in the context of certain very physically demanding jobs that are like that matter for safety, for example. So there might be certain parts of the military where it's actually the most fair thing, if you think about protecting a country, is to just have the people that are physically the strongest or something like this. So I do think that those kind of more strategic concerns can come into a conversation of fairness. I've excluded them primarily in this discussion, but I think that's a good point. Anyways, maybe I'll leave these as questions to ponder as you guys go about your day, as opposed to forcing you guys to give me answers. Okay, so I'm actually pretty close to time. So what I'm going to do is I wanted to introduce an area. So that was an example where using AI, while it might be helpful in some ways, it's ambiguous whether or not it's making things more fair, based on the data that I showed you guys. And I want to introduce a context where maybe it's a little bit less ambiguous, and a case where actually maybe AI can help, move us towards a fairer world. And so there, I'm thinking about cohort selection, diversity, and algorithms. This is really kind of a project about admissions, and I'm gonna go through this, fairly quickly, but. And since the banning of affirmative action in college admissions, a lot of organizations, schools in particular, are interested in figuring out how to diversify their college classes without using race. In the current climate, there's a lot of criticism of demographic diversification, and so criticisms of what's called DEI. But it's still something that I think is quite popular around different organizations. So this is a concern that maybe is worth trying to figure out if algorithms can help. The last thing I'll say on this is that the people who criticize demographic diversity oftentimes also have their own notions of diversity that they're interested in. So this is an example of an organization that has a libertarian-leaning heterodox academy that is interested in viewpoint diversity or ideological diversity on campuses, which is a kind of diversity. And so it seems like a lot of different sorts of organizations, whether it's demographic diversity or other forms of diversity, are interested in figuring out how to select diverse groups of people. And my thinking about this started when I was working with a prestigious scholarship called, actually I can't tell you guys the name, I have an NDA, I can't share that information, but I'm going to refer to them as the program for the sake of this. And so they were a scholarship that was interested in finding 15 to 18-year-old geniuses, like people who are right-tailed talent across different countries, to support them going to college. They give lifetime funding and support if they want to start organizations. They have seed funds, that kind of thing. And it's the selection is based on a competitive process that's based on applicant projects. They tend to be tech-oriented projects. And I started working with this organization because they were interested in optimally trading off between diversity and performance. How do they select people that in a way that accounts for both these elements? And they also had fairly clear notions of performance and diversity. So for performance, they have these scores that they give all the projects, and that's what they were thinking of as a cohort's performance, just sum all the project scores of the people in the cohort they select. For diversity, they were interested in selecting a cohort that was close to 50% female, 1/5 poor, 1/5 first generation, and they have a lot of different countries. There are over 100 countries that apply to the program, and so they wanted one person from each applicant country as well. And so this was their sort of notion of diversity. And so they were trying to figure out if we were to move in the direction of meeting our diversity goals, what's the optimal way to do that? How do we do this in a way that minimizes losses in terms of performance? I ultimately attempted to help them solve this problem. I think what I'm going to do is actually I'm going to skip over this simple example for the sake of time. Actually, I think I'm gonna let's do this. So the simple way of thinking about what their problem actually is they want to select a cohort of some size from a set of applications. They care about two characteristics, both performance and diversity. I've talked to performance, it's the sum of their project scores, but diversity, what I'm conceptualizing as a multi-dimensional proximity to the organization's compositional targets. So if they want 50-50 gender, if they, say, have, 60-40, you can characterize the distance from their goal or the proximity to their goal. Or if they want 20% to be poor, let's say they only have 10% that are poor in a particular cohort. You can characterize that distance and create a multidimensional proximity score. And then the organization really should just be surveying all the potential cohorts that they could construct that gets closest to their most preferred over these two characteristics. And so the way to think about this kind of a problem is that there are lots of different potential cohorts in diversity performance space. The ones near the top, top left, those are ones that are high diversity but low performance. The ones bottom right, those are high performance, low diversity. What you can do is you can construct what's called a selection possibilities frontier. It's the maximum achievable diversity for every level of cohort performance. And what the organization, what they're going to want to do is they will want to select their favorite cohort on that frontier. And so the nice thing about being on this frontier is that there are no cohorts that dominate if you're on the frontier. There aren't existing cohorts that are both better in diversity and performance, which you certainly want to eliminate. You do not want to select a dominated cohort. Now, the problem that we ran into, and this is where algorithms start to come in, is that technically calculating the selection possibilities frontier is complex. It's a hard problem. And the reason for that actually has to do with this diversity component. It turns out that each person's contribution to diversity is going to depend on the identity of every other member in the group. And so there's no such thing as individual diversity. It's a group concept. And so because of this, in order to determine which is the most diverse cohort, or the one that's closest to their ideal, you actually need to look at every possible cohort you'd form and figure out which one gets closest to your desired composition. And the challenge with that is that even when you have small sample size, small numbers of applications, you end up with effectively, a very difficult to count number of applications. So imagine in our context, there are 2,000 applications. You're choosing a cohort of 500. And it turns out that this would require actually evaluating, comparing, 5.6 times 10 to the 486th number of cohorts in order to know which one's the closest. Now, there are estimates of the total number of atoms in the known universe, and this number is about that number raised to the 6th. So it's an intractable problem, to say the least. And so, formally, for people that are interested in computer science or complexity theory, the problem is NP hard, which means that there's no algorithm that can compute the answer in a reasonable amount of time, or an exact answer. There are some special cases. So if you just have two groups, for example, then you can solve this, quite simply. But in general, the problem is complex. And so I'm now just going to, give an overview of kind of how algorithms help solve this problem. So really, there's like effectively an infinite space of different cohorts you can look for, and you have to search in order to get to the frontier. And what an organization typically will do in the wild is kind of select the one that seems best to them, but they're leaving a lot of potentially better cohorts on the table. And what would be nice would be able to estimate this frontier, to have some sort of procedure that can get you closer to this frontier so that you could do substantially better. And so what I ultimately do in this project is I actually generate an algorithm that attempts to estimate this frontier that's based on what's called greedy optimization. And it uses this procedure over and over again in order to trace out a frontier. Just to give a brief overview of what is greedy optimization. What a greedy optimization process is you make a series of iterative decisions where you try and maximize the increase in some objective function at each choice, and you basically don't care about global optimization. And so the way that you can apply it to this problem is that you can actually have an objective function, which is the weighted sum of performance and diversity, and you start with an empty cohort, and you add people who increase this objective function the most. So it's a very sort of almost simplistic or naive approach to trying to solve this problem, but it ends up working fairly well. And then once you keep adding people till you get to the total cohort number, you finish once you actually, you get to n members, which is the number that you want to have. You do this process now weighting diversity and performance differently. So you first you initially weight only performance, and then you give a little bit of weight to diversity, and then you give a little bit more weight to diversity, and you do this procedure over and over again, and that gives you different points on the frontier. One way of thinking about this simply is to say, essentially what this does is it gives bonus points to people who are in particular groups that you want to represent, but it adjusts those points as you get close to the number of people that you actually want to represent in your group. And so if you met the target, you no longer get those additional bonus points in your cohort. And so, what that ultimately cashes out as is, you have this estimate of the frontier. How do you get this? You run this greedy optimization procedure once, you get a point on the frontier, you run it again, you get another point, and this allows you to trace out the entire frontier. And the idea is that now you can actually pick a cohort that's closer to the actual selection possibilities frontier. to sort of conclude and show why this actually mattered in an actual organization, what I could do is I can estimate this frontier of diversity versus performance for the scholarship that I was looking at, and I could compare the actual cohorts that they had been selecting. And so you can see that for the first cycle, they selected someone well within the estimated frontier that I had calculated, and so you could have improved diversity substantially without reducing performance, or you could have improved performance without changing diversity. You see the same thing in the second cycle, that they left a lot of these gains on the table. And what I ultimately do is I gave them access to this technology that I had developed with my co-author. And in the third cohort, you see a different story. So in the third cohort, you see them select very, very close to the frontier. And the reason why this example is one that I'm getting really excited about for research is that it's a case where actually there were improvements on what people would consider merit and what people would consider diversity. You didn't actually need to sacrifice one of those dimensions. And I think I'll conclude with this. I asked whether or not algorithms are going to make the world more fair at the beginning. I think in some cases it's hard to see whether or not they will. I think the context matters a lot. But the thing that I think makes me optimistic is that there are a number of problems that are simply intractable for people to be able to figure out, that are fundamentally fairness problems, that the kind of characteristics algorithms have, I think, make them much better at trying to solve those problems. In cases like this, humans left to their own devices, maybe we're doing something both less effective and less fair. So I'm going to wrap up with that. I know I'm way over time. There were some questions for you guys, but thanks for having me.